guys, let's continue. So today our topic is Laplace inverse by partial fractions. For those of you who don't know, partial fraction is when we break something like this into two parts, like a upon s plus c plus b upon s plus d. So I'm gonna make a table so that you guys know how to break the fraction. So if it's like this, you're gonna break it like this. So if you have the actual factor inside, then you can directly break it into two parts. But what if you have something like this? PS is basically a polynomial of s. What if you have something like s square plus as plus b into s plus c? Now, what if this cannot be broken into two factors? So here you will write a upon s plus c. For this one, you can directly break it. Plus for the next one, you'll write bs plus c divided by s square plus as plus b. Let's look at the next type. The next type is if you have ps divided by s plus a into s plus b whole square. So as you know, this one you can break it directly. You can write a upon s plus a. But for this one, it is whole square. So what you will write? You will write b upon s plus b plus c upon s plus b whole square. If you have whole cube over here, you'll write b upon s plus b plus c upon s plus b whole square plus d upon s plus b whole cube. If there was a cube over here. Alright. So this is how the pattern goes. So this is basically what you have. Now whatever questions will come, it will be in the combination of these three only. So you guys will need a lot of practice to get the hang of this. So I'll start with the most simple one. So for example, your question is Laplace inverse of 1 upon s plus 1 into s plus 2. Now you cannot directly take the Laplace inverse of these as they are multiplied together. So we need to write this as, so let's write it like this. Now as you know, if you have a direct factor s plus a, you can break it into a upon s plus 1 plus b upon s plus 2. Now let me show you how to solve this. So we are going to be taking LCM over here. So the left hand side remains same, but here we'll write a multiplied by s plus 2 plus b multiplied by s plus 1 divided by s plus 1 multiplied by s plus 2. So this gets cancelled. So now what do you have? You have 1 is equal to a multiplied by s plus 2 plus b multiplied by s plus 1. Now basically we need the values of a and b because these are some constants that we have assumed. So we need the value of this. So the easiest way to solve this is you make one term 0. So if I put s as minus 2, this entire term will become 0. So when you put s as minus 2, you get 1 is equal to 0 plus b into minus 2 plus 1. So you get 1 is equal to minus b. That means b is equal to minus 1. Similarly, if I want this term to vanish, I will put s as minus 1. So you will get 1 is equal to a minus 1 plus 2. So you directly got a is equal to 1. So you can write 1 upon s plus 1 into s plus 2 as 1 upon s plus 1 minus 1 upon s plus 2. Now we can take the Laplace inverse on both sides is equal to Laplace inverse of 1 upon s plus 1 minus Laplace inverse of 1 upon s plus 2. So this becomes e raised to minus t minus e raised to minus 2t. This is your answer. Now let's take a slightly different example. Let's go with this. Laplace inverse of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5. Now remember guys, this is not broken into factors such as s plus a or s plus b. So here we need to use the second form. We need to use this form. So let's write this as, let's take the LCM. Let's first write this, then we'll take the LCM. S minus 1 into s square plus 2s plus 5. I'll write this as a upon s minus 1 plus bs plus c divided by s square plus 2s plus 5. Now let's take the LCM. 5s plus 3 is equal to, or I'll just write the denominator as well, then we'll cancel it, divided by s minus 1 into s square plus 2s plus 5 is equal to a multiplied by s square plus 2s plus 5 plus bs plus c multiplied by s minus 1 divided by s minus 1 into s square plus 2s plus 5. So now we can cancel the denominators. So you got 5s plus 3 is equal to a into s square plus 2s plus 5 plus b s plus c into s minus 1. So now when I want to cancel a term, I cannot cancel this one, but I can cancel this one. So let me put s as 1. So you will get 5 into 1 plus 3 is equal to a into 1 square plus 2 plus 5 plus b into 1 plus c into 0. So this term will get cancelled. So you got 8 is equal to 8a. So you got a is equal to 1. Now guys, when you cannot cancel a term directly, the easiest things to do is to take s as 0, 1, minus 1. So let's do that. Let's put s as 0. So you get 0 plus 3 is equal to a into 0 plus 0 plus 5 plus b into 0 is 0 plus c into 0 minus 1. So you got 3 is equal to 5a minus c. Now we already know the value of a. So you can write this as 5 minus c. So c becomes 5 minus 3. So the value of c is 2. Now we still need to find b. So let's put s as 2. You can use any number. You can go with 1 minus 1 as well. We already did 1. We already did 0. You can go with minus 1 as well. I'm trying with 2. So you'll get 5 into 2 plus 3 is equal to a into 2 square plus 2 into 2 plus 5 plus 2b plus c into 2 minus 1. So you get 13 is equal to 4 plus 4 plus 5. 13a plus 2b plus c into 1. So the value of a is 1. 13 plus 2b plus the value of c is 2. 13. So you get 2b is equal to minus 2 and b is equal to minus 1. Now let's write the entire thing again. So Laplace inverse of 5s plus 3 divided by s minus 1 into s square plus 2s plus 5 can be written as Laplace inverse of 1 divided by s minus 1 minus bs plus c, right? So the value of b is minus 1 minus s upon s square plus 2s plus 5, and the value of c is 2, plus 2 upon s square plus 2s plus 5. So let's zoom in here. What can I write this as? 1 upon s plus s minus 1, the Laplace of that can directly be written as e raised to t, minus Laplace inverse of, now let's modify the denominator. I can write this as s plus 1 whole square plus 4. Now since the denominator has s plus 1, you also need s plus 1 in the numerator, but you only have s. So you're gonna write this as s plus 1 minus 1 plus Laplace inverse of 2 divided by again s plus 1 whole square plus 4. Now guys, let's separate these terms. So this becomes e raised to t minus Laplace inverse of s plus 1 divided by s plus 1 whole square plus 2 square. Minus minus becomes plus 1 up Laplace inverse of 1 upon s plus 1 whole square plus 2 square plus twice of Laplace inverse 1 upon s plus 1 whole square plus 2 square. Now guys, if this term was simply s divided by s square plus 2 square, you could have written cos 2t. But because we have s plus 1, you need to multiply it with e raised to minus t. Similarly, this term, if it was 1 upon s square plus 2 square, you could have written it as half of sine 2t. But again, we have s plus 1, so you need to multiply it by e raised to minus t. So let's continue. So this becomes e raised to t minus e raised to minus t cos 2t plus, guys, we can add these terms. This is 3 times Laplace inverse of 1 upon s plus 1 whole square plus 2 square. So this becomes e raised to t minus e raised to minus t cos 2t plus 3 times 1 by 2 sine 2t. So this is your answer. It's e raised to t, multiplied by e raised to minus t because of the shifting theorem, minus e raised to minus t cos 2t plus 3 by 2 e raised to minus t sine 2t. This is your answer. So guys, the partial fraction method can get a little lengthy, so you need to practice a lot to build up speed, and there are lots of examples in the notes. Please go through them, and if you guys have any doubts, leave them in the comment section. I'll answer. Thank you.